Good morning to one and all. My name is Sumaya Fatima. I'm studying in BSc Biotechnology final year from Giraj Government College, Nizamabad. First of all, I welcome you all to this session of series. And today I'm here with the topic of nitrogen compounds. Under nitrogen compounds, we will be dealing amines. So, let's have a look at what we are going to deal today. Under amines, we will be seeing the classification of amines, followed by the nomenclature of amines. After that, we will have a quick look on the structure of ammonia, followed by ring flipping, and after that, we will be seeing some of the preparations of amines. After that, we will be seeing some of the physical properties of the amines and uses of amines as a phase transfer catalyst. And lastly, we will see some of the named reactions that includes carbylamine reactions and Hofmann's mustard oil reaction. So let's begin our session with the understanding of what amines actually are. Amines are organic compounds. They are the derivative of ammonia. They are formed by the replacement of hydrogen atom with the alkali group. As we know that the nitrogen contains 3 hydrogen atoms, so from these 3 hydrogen atoms are getting replaced by alkyl group one by one or one after another, giving us the product known as the amines. Now let's have a look over the classification of amines. Based on the number of alkyl groups, amines are classified as follows. They are: when in an ammonia, one hydrogen atom is replaced with one alkyl group, giving us the product having the general formula of RNH2 is said to be primary amine. Or when in an ammonia, 2 hydrogen atoms getting replaced by 2 alkyl group, giving us the product having the general formula R2NH is said to be secondary amine. Lastly, when in an ammonia all the 3 hydrogen atoms get replaced by alkyl groups, giving us the product having the general formula of R3N is said to be tertiary amines. Along with the primary, secondary and tertiary amines, we have quaternary ammonium salts, whose general formula is R4N plus X minus, where X can be any halide or any electron-rich species. So this was the classification of amines, where we have seen the primary, secondary, tertiary amines along with the quaternary ammonium salts. Let's moving forward towards our next topic, which is nomenclature of amines. Well, nomenclature of amines is very important for any chemistry student with which we can give name to any chemical compound. First of all, here we will be discussing the nomenclature of primary amines. As we know that in the nomenclature we are following 2 systems. One is common system, another one is IUPAC system. Here IUPAC stands for International Union of Pure and Applied Chemistry. So for the primary amine in common system, we are naming it as alkyl amine. Whereas in the IUPAC system, we are naming it as alkanamine. Let's understand this with the help of an example which is given below. As you can see in the slide that the nitrogen or the amine group is attached to one methyl group. So we are calling this compound in common system as methyl amine. When it comes to the IUPAC system, we are calling this compound as methenamine. So this was the nomenclature of primary amine. Now moving forwards to the next one, which is secondary amine. In secondary amine, there are 2 cases: symmetrical secondary amines and unsymmetrical secondary amines. What are symmetrical secondary amines and unsymmetrical secondary amines? We will see. When amine is attached to the 2 alkyl group which are similar are said to be symmetrical, or when amines are attached to different alkyl group are said to be unsymmetrical. Now in the symmetrical, in common system, we are following or we are naming the compound as dialkyl amine, and in the IUPAC system, we are naming the compound as N-alkyl alkanamine. Let's have a look over this example. As you can see in the example, one nitrogen atom is attached to two methyl group. So name of this compound in the common system will become dimethylamine. As two groups are similar, that's why dimethylamine. Whereas in IUPAC system, the name of the compound will become N-methylmethanamine. So this was about the nomenclature of symmetrical secondary amine. Next, about unsymmetrical amines. So in unsymmetrical amines, in common system, we are following the naming would be alkyl amine, and in the IUPAC system, the naming will become N-alkyl alkanamine. Let's have a look over this example. As you can see in the example, the nitrogen atom is attached to one methyl group and another ethyl group. As two groups are different or dissimilar, the naming, hence we are calling it as unsymmetrical. So naming of this compound in common system will become ethyl methyl amine. Here we are following the alphabetical orders. First come E followed by M. So ethyl methyl amine. Whereas in IUPAC system, we are following the alphabetical orders. We are going according to the number of carbon atoms, from less number of carbon atoms to more number of carbon atoms. So the name of this compound in IUPAC or IUPAC system will become N-ethylmethanamine. Here capital N indicates the linkage with nitrogen atom. So this was the nomenclature of unsymmetrical secondary amines. Next, the nomenclature of tertiary amines. In tertiary amines, in common system, for the symmetrical ones, we are naming the compound as trialkylamine, whereas in IUPAC system, we are naming the compound as N-N dialkyl alkanamine. Let's have a look on this example to get a clear idea about nomenclature. Here, as you can see, the nitrogen atom is attached to three methyl group. These three alkyl groups are similar. That's why it is said to be symmetrical. It is said to be symmetrical. In common system, we are following the naming trialkyl amine, whereas in IUPAC system, we are naming this compound as N-N dialkyl alkanamine. Let's have a look on this example. As you can see here, the nitrogen atom is attached to three methyl group, so the name will become trimethylamine in the common system, and in the IUPAC it will become N-N dialkyl dimethylmethanamine. So this was the nomenclature of tertiary symmetrical amines. Now next, the nomenclature of unsymmetrical tertiary amines. So for naming unsymmetrical tertiary amines in common system, the naming would be alkyl amine. Here we are following the alphabetical orders, whereas in IUPAC system, we are naming this compound as N-alkyl alkanamine. Here we are going according to the number of carbon atoms. First, we are considering the carbon at less number of carbon atoms followed by more number. Let's have a look over this example. As you can see in the picture, one nitrogen atom is attached to methyl group and ethyl group and next it is attached to one propyl group. As the three alkyl groups are completely different, it is said to be unsymmetrical. So name of this compound in common system will become ethyl, methyl, propyl amine. We are following the alphabetical orders. First comes ethyl, E, next comes methyl, M, after that propyl, P. So name of the compound would be ethyl methyl propyl amine. In IUPAC, we are following or we are going according to the number of carbon atoms. So methyl or methane contain 1 carbon atom, ethane contain 2 carbon atoms, whereas in propane 3 carbon atoms are present. So name of this compound will become N-methyl, N-ethyl propanamine. So this was about the nomenclature of primary, secondary and tertiary amines. Next topic is structure of ammonia. It is very important or crucial for a student to understand the structure of ammonia, because the entire topic or concept or history of nitrogen compounds revolved around ammonia, or I can say it is derived from the ammonia. As you can see in the picture, the nitrogen atom is attached to 3 hydrogen atom with the help of 3 sigma bonds. The chemical formula of ammonia is NH3, indicating 1 nitrogen atom and 3 hydrogen atom. Here nitrogen is in the sp3 hybridization, and also it contains 1 lone pair of electron. When it comes to sp3 hybridization, the expected structure of the molecule is tetrahedral and the angle is 109.5 degrees. But here, due to the presence of lone pair and bond pair repulsion, the structure gets distorted. That is, the hydrogen groups will tend to close together or tend to come together, changing the structure of ammonia. It changes from tetrahedral to pyramidal. As the structure changes, we all know that the bond angle also changes. So it will become, or the bond angle changes from 109.5 degree to 106.8, or sometimes we also consider it as 107 degree. So this was about the structure of ammonia, that it is pyramidal, having a bond angle of 106.8 or 107, where the nitrogen atom is in the sp3 hybridization. We should know that in amines or in nitrogen compounds, all the molecules are derived from ammonia. So ammonia is the main source for this entire topic. So it is necessary for a student to have a clear idea about the structure of ammonia. So I hope that you guys are clear with the structure of ammonia. Let's move forward towards our next topic, which is ring or pyramidal flipping. This is one of the beautiful phenomena exhibited by the amines. When nitrogen atom is attached to 3 different alkyl group, or I can say in amines or in tertiary amines, when the alkyl groups are dissimilar or different, it is said to be chiral. I will give you an example so that you guys could have a clear idea about chiral compounds. Suppose when in nitrogen, one alkyl group is methyl and another alkyl group is ethyl, and next one is propyl. As these 3 alkyl groups are different, it is said to be chiral. So these chiral molecules usually exist in enantiomeric forms. Now what are enantiomers? These are the new term for us. Let us understand what actually enantiomers are. Enantiomers are the isomers. They are mirror images of one another, but they are superimposable. just like our hands. They are mirror images of one another, but they are superimposable. When you are putting one hand over the another, it doesn't fix, or we can call it as it superimpose. Hence, we can define enantiomers as the isomers which are the mirror images of one another but superimposable. As the chiral compounds existing in the enantiomeric forms, so it will become very difficult for us to isolate them, or I can say that the resolution of these enantiomeric forms becomes impossible, because these two enantiomeric forms interconverge very rapidly. Let's have a look on this slide where you can see the two pictures. Have a look on the first picture and on the last. As you can see, the structure of this chiral compound is completely getting inverted. In the first structure, to the nitrogen atoms, the alkyl groups are attached, which are different. These alkyl groups are present at the bottom, whereas when you notice the last structure, all the alkyl groups are coming upside. So structure is getting totally inverted or flipped. Just imagine an umbrella. Imagine that you are carrying or holding an umbrella, and when umbrella gets caught in heavy wind, how it gets upside down, how it gets inverted. Just like the same, here the chiral compounds are getting inverted or flipped completely. And this flipping or inversion occurs very rapidly within the fraction of seconds. That's why it becomes very impossible for us to isolate or separate any one of the enantiomeric form. This is also called as ring inversion. You guys may wonder why ring inversion, where there is no involvement of ring. As you can see in the slide, there is no ring. These are just aliphatic compounds. No rings are there. So why ring? Why the name ring has given to this phenomenon? This is because this phenomena of flipping or inversion was first observed or noticed in a cyclic or a ring containing compound. Hence, the name become ring inversion. Or as the structure of this chiral compound is pyramidal, we are also calling it as pyramidal inversion or ring inversion, as you have seen in the previous slide. So this was about the ring inversion or pyramidal inversion. Moving forward to our next topic, which is preparation of amines. Today we are going to see 5 important preparation methods of amines. These methods are very, very important for the examination point of view as well as for the entrance purposes. It will help the students who are preparing for the chemistry PG entrances. So one should remember what is the product, what are the reactants, and what is the catalyst which is involving in this reaction. So our first reaction is a monolysis of alkyl halide. Here, as you can see, the ammonia is reacting with the alkyl halide. When ammonia is reacting with the alkyl halide, one hydrogen atom is getting replaced by one alkyl group, giving us the product having the general formula RNH2. As you can see in the first step, we are getting the product having the general formula of RNH2. It is said to be primary amine. Now this reaction doesn't stop. It goes on continue. Next, here in the primary amine, one hydrogen atom is getting replaced by another alkyl group, giving us the product having general formula of R2NH. R2NH is secondary amine, as I have told you earlier that in the secondary amines 2 hydrogens gets replaced with the 2 alkyl groups, giving us the product having the general formula R2NH. It is said to be secondary amine. Now still alkyl halide comes and involve in the reaction where last hydrogen atom gets replaced by the alkyl group, giving us the product having the general formula of R3N. The products in amines having the general formula or contain R3N is said to be tertiary amines, which is followed by again addition of alkyl halide. Now here the entire alkyl halide gets added to the tertiary amines, giving us the product having general formula of R4N plus X minus. This is known as quaternary ammonium salt, where X can be any halide or electron rich species. So as you can see, in the ammonolysis of alkyl halide, we are getting primary amines as well as secondary amines, then tertiary amines, followed by the quaternary ammonium salt. This was the first preparation method of amines. Next is Gabriel synthesis. We will look directly at the reaction. This method is mainly used for the synthesis of primary amines. In the Gabriel synthesis, phthalamides reacts with the potassium hydroxide, giving us the product named potassium phthalamide, which is again react with the alkyl halide, which is again goes on hydrolysis, that is addition of your water molecule, or it may also react with the hydrazine, who's having the general formula of N2H4. Finally, this reaction yields primary amine. So the main criteria of this reaction is to prepare primary amines. This was about the Gabriel phthalamide synthesis. Next reaction is Hofmann bromides degradation. In this reaction, amides react with the bromine in the presence of alkali and yields primary amine. Alkali means bases that can be potassium hydroxide or sodium hydroxide, but here we are considering sodium hydroxide. So as you can see in the reactions, amides are reacting with the bromine and yielding primary amines. Why the name degradation has given to this reaction? Let's see. We are getting amines by the degradation of carbonyl group. As you can see in the reactant side, C double bond O group is disappearing to give us amine, or I can say to obtain amines there occurs the degradation of carbonyl group when it reacts with the bromine. Hence the name of the reaction will become Hofmann bromide degradation. This reaction mainly yield primary amines. As you can see at the product sides, we are getting a product having the general formula of RNH2, which is the primary amine, followed by next reaction, which is reduction of amines. Now let's understand what is reduction. Addition of hydrogen atom is said to be reduction, or removal of oxygen is also said to be reduction. But here we are considering these two phenomena. In reduction of amides, amides react or undergo reduction in the presence of lithium aluminium hydride, yielding primary amine. Lithium aluminium hydride is a very good reducing agent. It undergoes oxidation by reducing another or the compound. So as you can see in the amides, the oxygen is getting eliminated and the addition of hydrogen atom is taking place. So we are getting RCH2NH2, which is nothing but the primary amine. Let's have a look or recap this reaction. Amides in the presence of lithium aluminium hydride or ether, which are very good reducing agents, undergoes reduction, giving us primary amine. This was the reduction of amides. Now our last reaction is Smith reaction. Whenever any carboxyl group reacts with the hydroxoic acid in the presence of concentrated H2SO4, that is your sulfuric acid, we are calling such reactions as Smith reaction. As you can see in the reaction, the carboxylic acid reacts with the hydroxoic acid. The chemical formula of the hydroxoic acid is N3H. In the presence of concentrated sulfuric acid, we will get primary amines. Along with the primary amines, we will get carbon dioxide and water molecules. But here we need not to bother about these carbon dioxide and water molecules because these are the byproducts. Our main criteria or the main motto is to get amines. That's what we are getting in this reaction. This is one of the important reaction for examination point of view. So till now we have seen the 5 preparation methods of the amines, which are ammonolysis of alkyl halide. First we'll go to that slide. Ammonolysis of alkyl halide, that is the first reaction which we have seen, and the next one is Gabriel synthesis, followed by Hofmann bromide degradation, and next we have seen the reduction of amides. After that we have seen a beautiful reaction known as Smith reaction. So these 5 were the preparation methods to obtain primary amines. Now let's move to our next topic, which is physical properties of amines. Well, lower amines are gaseous in nature, middle ones are liquid, and higher amines are solid in nature. As you can see, while coming from lower amines to higher amines, amines are changing their physical state from gaseous to liquid and from liquid to solid. This is because increase in intermolecular interaction. Consider methylamine as a lower amine because it contains only 1 carbon atom. Middle amines, they contain like 6 to 7 carbon atoms. In higher amines, 10 to 20 carbon atoms are present. So as the number of carbon atoms increasing, the intermolecular interactions in the amines increases. Hence, amines tend to change their physical state, which are from gaseous to liquid and from liquid to solid. One important point that I would like to mention, that amine gives the fishy odor. The smell of the amines will be rotten fish. This was the point that I want to put a light on that. Next is basic nature of amines. Well, I can say that amines are weak bases. This property of the amines is due to the presence of one lone pair of electrons on the amines. I have told you in the previous slides that the nitrogen contain one lone pair of electron. So as nitrogen is having one additional electron, it wants to donate the other species, it wants to help the other electron deficient species. So it tends to donate electron to the incoming species, where here it is very helping nature. So as it is donating its lone pair of electron to the incoming species, it is said to be Lewis base. Again, clear with the topic. Lewis base are electron pair donor, whereas Lewis acid are electron pair acceptor. Most of the students get confused that what are Lewis bases and what are Lewis acid. So here amines, as they are donating their lone pair of electrons, they are said to be Lewis base. Next, basic nature of amines and ammonia. Here we will compare the basic nature of amine and ammonia. So amine versus ammonia. I can say that amines are stronger base when compared to ammonia. This is because the inductive effect of alkyl group. We will justify why and how this is happening. As you can imagine the structure of amines, the nitrogen atom is attached to one alkyl group. This alkyl group tends to donates its electron, not completely but partially. So the electron density on the nitrogen atom increases. As the electron density on the nitrogen atom increases, it tends to donate its electron pair. Hence, it is acting as basic. Whereas in ammonia, there is no alkyl group, so ammonia can't donate its lone pair of electron that easily. The order of basicity in gaseous state follows the order of tertiary amines greater than secondary amines greater than primary, because tertiary amines 3 alkyl groups are present, and in secondary 2 are present, and in primary only 1 alkyl group are present. So the order is as follows. Now when compared to the aqueous state, the order is completely getting flipped. It will become secondary amines are greater than primary amines are greater than tertiary. This is because the steric effect and the hydration effect. Steric effect refers to the crowding of the alkyl group around the nitrogen atom, and the hydration effect refers to the stabilization of protonated amine by water molecule. So by considering these two effects, we are coming to a conclusion and giving this order as secondary amines greater than primary than tertiary, which suits these two effects. So this was about the basic nature. As you can see how the basicity varies in the gaseous phase as well as in the liquid phase. In gaseous phase, the order is tertiary, secondary followed by primary. In aqueous state, the basicity order is secondary greater than primary greater than tertiary. Now moving forward, we are going to see two named reactions. First, we will be seeing carbylamine reaction. In the carbylamine reaction, any amine group reacts with the chloroform in the presence of base. Here potassium hydroxide we are taking it as a base. So amines react with the chloroform, giving us isocyanide. As you can see in the example, where aniline is reacting with the chloroform in the presence of potassium hydroxide, giving us benzene isocyanide. So in carbylamine reaction, what we are getting? We are getting isocyanide products. This was the first reaction. Now next is Hofmann's mustard oil reaction. Hofmann's mustard oil reaction, in this primary amines, as you can see in the slide, we are taking ethanamine, which is the primary amine, reacts with carbon disulfide. The structure of carbon disulfide is similar to that of carbon dioxide, which is linear. So, primary amines reacts with the carbon disulfide, giving us the product as alkyl isothiocyanate. We can understand this reaction with the help of this following equation, where ethanamine is reacting with the carbon disulfide in the presence of HgCl2, giving us the product known as ethyl isothiocyanate. Why the name mustard oil is given to this reaction? Because the product that we are getting gives us the foul smell. This smell just similar to that of the mustard oil. That's why the name becomes Hofmann's mustard oil reaction. So these were the two reactions that we have seen. First one was carbylamine reaction, followed by Hofmann's mustard oil reaction. These two were the name reactions, important named reaction in the chapter of amines. Now last, we will see the use of amine salts as the phase transfer catalyst. Catalysts are nothing but the chemical substances which changes the rate of reaction without getting any permanent change. They don't change their structure permanently, but they increases the rate of reaction. Here, quaternary ammonium salts, who is having the general formula of R4, N plus, X minus, are used as phase transfer catalysts. Here phase doesn't refer to any change in physical state. Many of the students, by listening the term phase transfer catalyst, will think that maybe the molecules or the compounds are changing their physical state, but it is not like that. We will justify this term. This catalyst is the heterogeneous catalyst because atoms are different. That's why heterogeneous catalyst. Sometimes what happens, reaction occurs very slowly and we'll get the product in very long time. The yield will be very less. So, to overcome this problem, we are using quaternary ammonium salts as a catalyst. Whenever we are using quaternary ammonium salts as a catalyst, the reaction rate changes. It changes from slow to fast. Without the use of this catalyst, the reaction just occurring slowly, yielding the product in a very less quantity or in very long duration of time. But whenever we are using this catalyst, the rate of reaction fastened, the reaction occurs or goes very rapidly or speed, giving us the large quantity of the product in a very short duration of time. So this was one of the advantage of using quaternary ammonium salt as the phase transfer catalyst. I hope that you guys are clear with the term of phase transfer catalyst. Now with that, I will come to my conclusion, and let's just recap quickly what we have learned today. Today we have seen amines. We have defined what amines are, which are actually nothing but the derivative of ammonia. Followed by that, we have defined the classification of amines, which are primary amine, secondary amine, tertiary amines, and quaternary ammonium salt. After that, we have seen the nomenclature of amines. Next to that, we have seen the structure of ammonia, which is pyramidal, having the bond angle of 106.8 or 107, where nitrogen atom is in sp3 hybridization. After that, we have seen a beautiful phenomena known as ring flipping, which is also called as ring inversion. After that, we have seen preparations of amines. In that, we have seen 5 methods, which were ammonolysis of alkyl halide, Hofmann bromide degradation, Gabriel synthesis, reduction of amides, and last Smith reaction. In those 5 reactions, we have seen how we are obtaining or getting amines. After that, we have seen the physical properties of amines. In that, we have learned how the amines are changing their physical state from gaseous to liquid and from liquid to solid. And in that also, we have seen the basic nature of amines and ammonia, and lastly, we have seen some of the named reactions, which are carbamide reaction and Hofmann's mustard oil reaction. And lastly, we have seen one of the wonderful advantage of quaternary ammonium salt as a phase transfer catalyst. As a phase transfer catalyst, in that we have seen how the reaction rate is getting increased when we are using quaternary ammonium salt as the phase transfer catalyst. So this was my today's topic about amines in nitrogen compounds. I hope that you guys may find it interesting or you have enjoyed my class. So with that, I will conclude my today's topic, and I would like to thank TSAT team coordinator of TSAT, my principal sir, Dubarajan sir, my mentor Sunita madam, Madhav sir, and to all my chemistry department, my all lecturers who helped me a lot, who encouraged me a lot, and gave me this wonderful platform where I expressed myself. I thanks to all of you. Thank you.